let's get to it. So, when we add and subtract mixed numbers, there are quite a few steps and it can seem like a daunting task. So, because of this, what I'm going to do now is show you a simple step-by-step procedure, literally 5 easy steps to adding and subtracting mixed numbers. So, what we have here is 1, 2, 3, 4, 5. I have these here, but I'll explain them in a second. First, line up the numbers vertically by place value. 1b is estimate. You don't have to estimate your answer. It's not required, which is why I put it as a sub, but you should. 2 is write equivalent fractions. Then 3, perform operations. 4, rename mixed numbers if necessary. 5, simplify if necessary. And if you estimated originally, then lastly, compare answer with estimate. So those are the 5 easy steps to adding and subtracting mixed numbers. So what I'm going to do now is shrink this and save it for us to use later. So now we have this here, and I'm going to save it up in this space here so that we have it for use. Now we're ready to start working. Let's try the first problem. 1 and 4/5 plus 2 and 1/10. So I have my stuff here ready to go. I've got a problem. Now let's begin. Step 1. Line up the numbers vertically by place value. So that's what I'm going to do. 1 and 4/5 plus 2 and 1/10. And I put a sum line. Okay, I lined them up, so I'm going to get rid of this. I'm not in need of it anymore. And I'm going to move this up nice and high so that we can see it much better. Now, because I said that you should always estimate, but it's not required. So what I'm going to do now is write an estimate. Okay, I look at my 4/5. 4/5 is close to 1. So I'm going to think about it as 1. 1 and 1 is more like 2 plus 1/10. 1/10 is fairly close to 0. So I'm going to think about it as 0. So 2 and 0 would be 2. And when we add those together, we get 4. So our answer should be about 4. Somewhere around 4. That should be our answer. And what I'm going to do here is save this over here. And that way we'll be able to compare it later. Alright, now we're ready for step 2. Write equivalent fractions. Look at the fractions, 4/5 and 1/10. I need to find a common denominator so that I can write an equivalent fraction. If you've got your multiples down, you already know that 5 is a factor of 10. So when we write it, we want to rewrite it so that we have an equivalent fraction that we extend our line, and we want our denominator to be 10, so we do 5 times 2, which is 10, and we multiply the top by 2 also. And since we're keeping 10, when we do our multiplication down here, we just multiply it by 1. because 10 times 1 equals 10. Now, we're ready for our equivalent fraction or our equivalent mixed number. So now we have the 1 that was already there, and now we have 4 times 2 equals 8 over 5 times 2 equals 10. And now we write the other one. We have 2. And we have 1 times 1 equals 1. And 10 times 1 equals 10. You never want to forget this next part. It's to bring over the correct operation. We've been adding, so we're going to put our addition sign and a sum line. Okay, step 2 done. Now we move on to step 3. Step 3 is to perform operations. So let's do it. We have 8/10 plus 1/10. The denominators are the same now, so we just add the numerators. 8 plus 1 equals 9, and that's over 10. Very good. Now we move to the ones place. 1 plus 2 equals 3. Very good. So we performed operations. Step 3 finished. Okay, now we do step 4. Rename mixed numbers if necessary. That means that sometimes it might not be necessary. If you look at this, 9/10, 9 is less than 10, so we don't need to rename it. It's already all right. We don't need to do anything special with it. So we're done with step 4. All we need to do is check. Lastly is step 5. Simplify if necessary. Again, that doesn't mean that we have to. It just means we might need to. So, check. Is 9/10 in simplest form? The answer is yes, because 9 and 10 share only one common factor, and that's 1. They don't share any other ones, so it's simplest form. Okay, so we have our answer. Now, if you estimated like I did, you can compare the answer with the estimate. Let's grab that estimate that we had earlier and compare. 3 and 9/10 is about 4. And it is very close. 9/10 is very close to 1, so it's almost 4. 3 and the 1 that's almost 1 is about 4. So we know we did a good job. We checked for reasonableness, and it makes sense. 3 and 9/10 makes sense. So we probably did an excellent job based on what we have here with our estimate. Very good. Let's continue with another example. Okay. Next example. 5. Oops. Mistake. 5, the whole number. And 3/4 plus 1 and 1/3. Okay, we don't have common denominators. We can see that already. So let's go through the steps. Step 1. Line up the numbers vertically by place value. Let's do it. 5 and 3/4 plus 1 and 1/3. Sum line. Good, step 1 finished. So let's get rid of this. We don't need it anymore. We require extra space. So let's put this up here. And now we're ready to continue. As I said before, we should probably estimate. I like to estimate, but it's, again, not a requirement. But it helps us decide if our answer's right when we're finished. It's a good thing to do every time. Estimate. Okay, let's estimate. 3/4 is close to half and close to 1. It could be half or it could be 1. It's right in the middle. I'm going to say that it's close to 1. I'm going to round up. Let's say at 5, and this almost 1 equals 6. Okay? And then look at this one, 1/3. 1/3 is kind of close to 0 and kind of close to half. But since I rounded up with this one, I should probably round down with this one. Let's say that this is 0. So 1 and 0 would be 1. And if I add them together, I have 7. So my answer should be about 7. Very good. So I estimated, and I'm going to save this for later so we can compare when we're finished. Save it for later. And now we're good to go. We're ready to move on. Step 2. Write equivalent fractions. Well, I need to find a common denominator for 4 and for 3. We can use the idea of multiplying them against each other to come up with an equivalent fraction. So what I'm going to do is take 4 and multiply it by 3, and I'm going to take 3 and multiply it by 4. So I extend my line. 4 times 3 in the denominator and times 3 in the numerator. Going to do the same thing here, but use the opposite. 3 times 4 in the denominator and 1 times 4 in the numerator. And now I'm ready for my mixed number, but with a like denominator. I keep my 5, and 3 times 3 equals 9, and that's over 4 times 3, which equals 12. I keep my 1. Now I continue. 1 times 4 equals 4 over 3 times 4, which equals 12. And again, continue. Carry this over. We are adding, so we write our addition sign and our sum line. Very good. We finished step 2. We have our equivalent fractions now with like denominators, and we're ready for step 3. Perform operations. Now we add. Start with the fractions and move to the left. 9/12 plus 4/12. Well, since it's 12ths, they're the same, so we just add the numerators. 9 plus 4 equals 13. And that's over 12. Now do the ones place. 5 plus 1 equals 6. Very good. We performed operations. Now we move to step 4. Rename mixed numbers if necessary. Take a look at the fraction. 13/12. 13 is higher than 12. That means we need to rename the fraction. So this time we actually do need to do step 4, because last time we didn't need to. It was already okay, but this time we do need to do it. So let's rename. We're going to do some work on the side here so that we can figure it out, and then we'll erase it so that we have space. You don't need to erase it later, but I will so that you can see everything. So we take 13 divided by 12. 13 divided by 12. When we do the division, and because this is not the focus, I'm going to do it quickly. 13 divided by 12, we have 1 whole. When we multiply, subtract, and we have a remainder of 1. So, if we think about it quickly, instead of thinking of it as 13 twelfths, we can get rid of this and think of it as 1 and the remainder, which is like a part of a whole or a fraction, 1/12. And so that we're not thinking about this, we're just regrouping it now as 6 and 13 twelfths. And if we change it to the new amount, now we have 1/12, and we have 6 plus 1 equals 7. Okay, so now we renamed it. We have it, instead of 6 and 13 twelfths, it's renamed as 7 and 1/12. Okay, so that's step 4. We completed it. Now again, like I said, I'm going to get rid of this here by sliding it over so that it's just out of the way. Now we do step 5. Simplify if necessary. Look at the fraction, 1/12. Can you simplify it any further? The answer is no, you cannot. So 1/12 is in simplest form. Finished. Now lastly, we compare the answer with the estimate. Let's grab it and pull it over. Well, is 7 and 1/12 about 7? It is. It's super close to 7. 1/12 is almost 0. So it is about 7, and we did a good job. Very, very good work. Let's do one with subtraction now. Now would be a good time to try and take a break. Very, very good work. We're ready for subtraction. All right. Oops. Change my color. Four and 5/6 minus 2 and 3/4. All right, let's go. Step 1, line up the numbers vertically by place value. All right, 4 and 5/6 minus 2 and 3/4. Difference line. Now I quickly get rid of this. Oops. Just delete. And let's move this up here. All right. Next step. Again, this is optional, but I do it every time. Estimate. When I write an estimate here, I'm going to think about whether or not my fractions are close to 0, close to half, or close to 1. Let's take a look at this as 4 and 5/6. 5/6 is very close to 1, so I'll think about 5/6 as 1. 4 and 1 is 5. Now let's look at the next one. 2 and 3/4. 3/4 could be close to 1, or it could be close to half. Since I went up to 1 up here, I'm going to go down to half on this one. So I'm going to think of it as 2 and 1/2. And when I, excuse me, mistake, gotta pay attention to which symbol we're doing. We switched symbols and I almost made a mistake there. If we think about it as 2 1/2, then 5 minus 2 1/2 equals 2 1/2. So my answer should be about 2 1/2. Alright, we estimated. I'm going to grab all this and slide it here so that we can have it for later. Now we're ready to move to step 2, write equivalent fractions. Let's start writing. 5/6 and 3/4. Think about what common multiples 6 and 4 have. We could multiply them against each other like we did in the last problem, and we would do 6 times 4 and 4 times 6, and we would get a number that's up there higher. Or we could find the least common multiple. And if you know your multiples quickly, then you can find it. Let's do that. Multiples of 6 are 6, 12, 18, 24. Multiples of 4 are 4, 8, 12, 16, 20, and 24. What's the first one you heard that was in common? If you said 12, you're right. It is 12. So we're going to use 12 as our common denominator. So extend the line. Think to yourself, 6 times what number equals 12? The answer is 2. So we do 6 times 2 for the denominator and 5 times 2 for the numerator. Let's do the next one. Think to yourself, 4 times what number equals 12? If you said 3, you're right. 4 times 3 equals 12. So we do that to the bottom, and we also do it to the top. 3 times 3. Now we're ready to write the equivalent mixed numbers. Alright, we keep our 4. And now we do 5 times 2, which equals 10. And we do 6 times 2, which equals 12. We keep our 2. And we do 3 times 3, which equals 9. Over 4 times 3, which equals 12. Now, if you remember earlier, I made the mistake over here. I accidentally wrote the addition sign, and I'm very good at math. So if you're learning, you want to always make sure you check to make sure that you take the right sign. So let's take the subtraction sign and write a difference line. So now we have written our equivalent fractions. Now we do step 3, perform operations. Let's perform. Start with the fractions. 10/12 minus 9/12. The denominators are the same. This is why we do this. So now we can just do 10 minus 9, which equals 1. And that's going to be over 12. Now we do the ones place. 4 minus 2 equals 2. So, considering it all, now that we have our answer, we have performed operations. We're ready for step 4. Rename mixed numbers if necessary. Take a look at 1/12. Do you need to rename it? If you said no, you're right. 1/12 is already in good form. It's not greater than 1. We don't need to rename it. Now we move to simplify, if necessary. Is it necessary to simplify 1/12? If you said no, you'd be right. 1/12 is already in simplest form. 1 and 12 share factors of only 1. So we cannot simplify it any further. Last step. Compare answer with estimate. Since we estimated, we need to do this. So I'm going to grab this piece over here, and let's compare. Is 2 and 1/12 about 2 1/2? Yes. It's probably closer to 2 because 1/12 is closer to 0. But if you remember, when we originally did our estimate here, we probably could have said 3/4 was equal to 3 instead of thinking of it as 1/2, because that's close enough to 1 also. And if we had done 5 minus 3, it would have come out to be about 2. And this one is about 2. So depending on your estimate, it could be close, and it is very close. Very good work. Let's do one more. All right. One more problem. 7 and 2/3 minus 3 and 1/6. All right. First step, line up the numbers vertically by place value. Let's do it. 7 and 2/3 minus 3 and 1/6. Difference line. Okay, now we're ready to get rid of this. And we're going to move this up here. Nice and high. Alright. Now, let's do an estimate. Again, you don't have to, but I like to do them because it helps with deciding whether my final answer is correct. 7 and 2/3. 2/3 is close to 1, or it's close to half. Let's say that it's close to 1, and we do 7 and 1 equals 8. Let's do 3 and 1/6. 1/6 is close to 0. So let's think of it as 0. 3 and 0 is 3. And since we're subtracting, we can do 8 minus 3, which equals 5. So if we are thinking about it, our answer should be about 5. Well, I'm going to move this here now so that it's good and ready to go for when we need it later. Step 2, write equivalent fractions. 3 and 6 are different. We want them to be the same. So 2/3 and 1/6. Hey, look at that. 6 is a multiple of 3, so we can use 6 as our common denominator. So let's do it. 3 times 2 would equal 6. So we're going to multiply it by 2 on the denominator and the numerator. And since we're keeping 6, we just write times 1 for each of them. This is not a required step for this, but it helps with flow and making sure you don't skip any steps by accident. And now we write the equivalent numbers. 7 2/3 times 2. So now we keep the 7, and 2 times 2 equals 4 over 3 times 2 equals 6. Now with the next one, 3, we keep it. 1 times 1 equals 1 over 6 times 1 equals 6. And again, make sure you bring the correct operation over. Our operator tells us everything. Subtract and difference line. Good. Now we're ready for step 3, perform operations. Fractions first. 4/6 minus 1/6. Since the denominators are the same, it's just 4 minus 1, which equals 3. And that's over 6. Now we do the next one in the ones place. 7 minus 3 equals 4. Good. Done. Step 4. Rename mixed numbers if necessary. Is it necessary to rename 3/6? If you said no, you're right, it's not necessary. 3/6 is already in good form. Finally, step 5. Simplify if necessary. Is it necessary to simplify 3/6? If you said yes, you'd be right. It is necessary. When we do this, we can divide 3 and 6 by a common factor of 3. So we extend the line and divide by 3 on both sides. And when we do this, we have, keep the 4, and 3 divided by 3 equals 1. 6 divided by 3 equals 2. Now, did we simplify far enough? Do we need to do it again? Is it necessary? No, it isn't. So our answer is 4 1/2. Lastly, if we wrote an estimate, we need to compare it with the answer. So I grab it and I slide it. Is 4 1/2 about 5? The answer is yes, it is about 5. I want you to think about if we had estimated differently. What if we had estimated 7 2/3 as 7 1/2 instead of 8? Because we could have. If we had 7 1/2 minus 3, then our estimated answer would be 7 1/2 minus 3 would be 4 1/2. Our estimated answer would have been exactly the answer. So that's why when you choose your estimates, do the best you can, but 4 1/2 is close to 5. It's about 5. Excellent work. Excellent, excellent work. So, if we go back and we think to ourselves, when I add and subtract mixed numbers, I can always think to myself, right here, in these simple steps, line up the numbers vertically by place value. You can estimate or you cannot. That's optional. 2. Write equivalent fractions. 3. Perform operations. 4. Rename mixed numbers if necessary. 5. Simplify if necessary. And if you estimated, compare the answer with the estimate. Following these simple rules will get you all the way through adding and subtracting mixed numbers with unlike denominators every time. Great job. Now you're ready to do some on your own.